Hey everyone, welcome along to Work with Delta Lake Tables and Microsoft Fabric. I'm Greg Lowe. I'm a long-term Microsoft MVP and member of the Microsoft Regional Director Program, and I'm based out of Melbourne, Australia. And so my co-host here is Mariano. Welcome, Mariano.
Thank you, Greg. Hello, everyone. Good morning, good night, or good afternoon. My name is Mariano Kovo. I'm a Microsoft Data Platform MVP as well, and I'm located in Spain.
Awesome. And so, look, I also want to thank our moderator. We may even have more than one today, but Avinash is going to help us out in the chat as we go along through the material and try and answer any of the questions that you have. Obviously, we won't have a lot of time to be looking at the chat the whole time, but we'll try and make sure that things that come up in the chat get dealt with as they appear. And so, look, this session, if you want to follow along with us, there's the link there for AKMS Learn Live and our session number. You can follow that with the QR code. You can just click on that, and that gives you the opportunity to follow along with what we're doing if you want to do that at the same time. Also, as I said, please feel free to jump into the chat. This is meant to be a live and interactive session, and so pop into the chat, say hi, let us know where you're from. And as I said, if you have questions, push those in and we'll see what we can do along the way. And so, Mariano, how do we get started with Fabric?
The first thing that you can do if you want to jumpstart your career in Microsoft Fabric, you can take a look at the Microsoft Fabric Career Hub, which is https://aks.ms Fabric Career Hub. It's a complete website with a lot of curated resources to become a certified Fabric engineer. You can find advice from community leaders and mostly role guidance about the skills and tasks that comprehends the role of an analytics engineer inside Microsoft Fabric. Also, you have links to join multiple activities towards the certification. For example, the Cloud Skill Challenge, the Learn Together initiative that we are running right now, and the exam grammar practice test. As you can see, we are on the Learn Together, which is the step number 2. We are going to show some details and a walkthrough to the Learn model available at the Microsoft Doc, plus the Q&A. So it's all live. Please put your questions, and it will be recorded so you can watch it or rewatch it at your own pace. So the next thing that you can do is join the Cloud Skill Challenge at the Microsoft Learn website. It's for a limited time period, but if you complete all the modules, you will earn a 50% discount voucher for the certification exam. So please do it. Also, we have the exam cram session that will be happening the next May 9th, the 9 a.m. Australian time. This is a must-go session if you're going to take a real certification exam, because you will have here all the topics and all the tips and how to avoid common mistakes. So this is a must-go session if you are really taking the certification, okay? And these are all the dates for the Learn Together wave that we are showing here. Now we are with Greg on this third session, which is work with Delta tables. And the next session will be happening on next Tuesday for use data factory pipelines. So stay tuned and join all the sessions.
And with the learning objectives for this one, so this is to get you across what Delta Lake is and what Delta tables are in particular. And we'll have a look at the structure of those tables and what's different between just having files and having Delta tables instead. Then we'll also look at how to use Spark, which is the main place that we'll do query and transformation of the data. Although we can do that also using SQL in a warehouse, but we can combine we could even do SQL in Spark as well. So there's lots of options. And in addition, I'll show you some information around how we could use Spark structured streaming in conjunction with this. And so, look, the first thing is to have an understanding of Delta Lake itself. And so, the idea here is that if you look at most previous databases or storage areas where we've stored organizational data over the years, they typically always have some sort of proprietary data format. So if you've used SQL Server as an example, it has its own proprietary format for how the data is stored inside the database. And that's great. I mean, it works fine for that. However, if you wanted something else to be able to work at the same time or in conjunction with that same data, it needs to go through the SQL Server interface to be able to do that. Now, there's pros and cons for that, but what Delta Lake is an open an open source storage layer. And what that does, it takes data lake processing concepts from Spark and put relational database semantics over the top of that. One of the things that this is based on is the Parquet format for files. And so inside this, we've got Apache has defined how Parquet would work. And if you've looked at how storage has worked over recent years, most data warehouses have had some form of column-based storage that they use in conjunction with the database. If you look at how compression has worked, compression has been one of the main things that's produced big benefit in terms of working with large amounts of data. And so if you look at a traditional database, this is Postgres or SQL Server or even just files, the standard way that we lay these things out is that files that contain a whole series of rows, and we store the data row by row. Now, they did great work back in SQL Server 2008, where they introduced table compression. In fact, I thought that was the best thing in the box in SQL Server 2008. And they had options there to try and compress across a row, but that's very, very difficult to do. You can imagine if you take a row of data and you say, how could I compress this? That's incredibly tough to do. But if you then look down columns instead, you start to realize that there's a lot more opportunity to compress data that way. And in that case, they introduced page compression, which just took a page of data, but you were able to fit far more data on the page because it used column compression. Now, this was taken further with column store indexes in databases like SQL Server, and the same thing in Power BI, where we had the VertiPack format that was being used inside that as well. And so this allows you to get massive amounts of compression because what we're doing is storing the values in columns and then compressing down columns. And so, for example, this is what's used in the Parquet format. So instead of storing row by row all the data, what we do is we store separate files that contain each column. And then if you look at the example here, it said there's a first name column and we've got Abigail, Amanda, Melissa, Sarah, Isaac, and so on. We've got a last name column that stores those. And then we have is premium customer. It's got 1, 0, 1, and so on. Now, the first thing about this is that it allows you to do additional things like run length compression. So I'm able to say, look, is premium customer has this value, then this value, and then for the next 400 rows, it has this same value. So then I don't need to store that value for every single row. So I can get really quite detailed compression going on inside that. And so this is very, very powerful. The other thing is that if I'm running a query, I don't need to go and read all of the table. So for example, if I only need a query that has the last name and whether they're a premium customer or not, I can read just the files that are containing just those columns. And so that vastly reduces the amount of data that I need to read. And so this allows a completely different level of performance to be achieved, even over large amounts of data. Now, the thing that they have structured with the Delta Parquet format, rather than just having Parquet format, which was that basic file structure with the compression and the metadata with the columns and so on, a Delta Parquet format is actually a folder rather than just being an individual file. And what we have in that is the series of Parquet files are stored in a folder. And then to give it database characteristics, we've then added things over the top of that, like we've added a transaction log. And so there's a log directory with a whole series of files. We periodically break out and capture a checkpoint so that we don't have to go and read the entire list of log files if we want to go back over a period of time. But this then whole structure is considered a delta table. Now, what this allows us to do is to be able to have transactional inserts, deletes, updates, and so on. So we can have ACID-style transactions with updates, merges, and so on. We can also have versions of the data. So I can say, look, I want to go back and look at what the data looked like at a specific point in time. That's possible as well. And then in addition to that, I could say things like, show me what the data looked like at yesterday afternoon at 5 o'clock. And so I've got the ability to do a form of time travel with that happening as well. Now, to create the delta tables, I'll get Mariano show us what happens when we need to then start creating delta tables, because this is a couple of things involved. One is that we define in what's called the meta store the definition of the table, and then the data for the tables end up in the Parquet files on the folder for the table.
Exactly. As Greg mentioned, we have two things: the meta store, which is the definition, and the data, which is all the files that are underlying Parquet files storage. So you can have two types of tables when you create tables on Fabric. The ones that are called managed tables and the non-managed or external tables. They are both stored on the same Open Delta Parquet format, but they have a couple of differences, okay? So depending of the use that you're going to use with those tables, depending on their use case, location, data retention, or integration with other tools, you will choose one of another. In the case of use case, in the case of managed tables, the data management should be handled only by the Fabric Spark engine. In the case of the external table, you will use existing data sets managed outside of Fabric, okay? So that's the basic difference. In terms of location, all the tables that you create in the terms of managed tables will be created on the tables directory. Yeah, this is a specific directory that resides on Microsoft Fabric. In the case of external tables, you as a user, you will be specifying the location for those files, okay? Obviously in the same lakehouse. In terms of data retention, the important thing is when you create the managed table and delete that table, all the data is dropped, okay? So you will lose definition and the table. In the terms of the external tables, when you delete an external table, you delete the definition, but not the data. So you can reuse it later, okay? And in terms with integration with other tools, it's obviously great inside Fabric. And if you're going to use third-party tools, the access will depend if they can access or not to the lakehouse. From the other side, external tables are great in Fabric as well, and it's easier to access the data, the underlying data, because they are stored on a specific location. In both cases, they support ACID transactions, batch or streaming processing, and the metadata handling is the same. And the performance, which of course is important, it should be similar for both type of tables when you create with the right options, okay? So let's see some examples how to create a data table. You can choose for several languages. We are talking about Python or Spark SQL. When you create a managed table from data, you will using Python, for example, you're going to use the write command, and the format will be delta, and we are saving a data frame as a table with the name. And if you're using a Spark SQL, you will use just a regular create table statement, but using the property using delta, and we are selecting data from an existing table. Okay? If we are creating an empty table and just the definition of the schema, in Python, you will create the delta table create with the name of the table, and you will specify all the columns that you need. And if you're using a Spark SQL, you will just create a table, just a regular create table statement, and you will add the property using delta. So all the metadata you create, the Fabric engine will handle all the Parquet files. In the case of an external table, the difference is that you will add, in the case of Python, you will add the path sentence to specify the location of that data. And if you're using a Spark SQL, you will add the location property, so the external table can be created on the specified folder. And if you're just creating the schema, you will specify as well the delta location and put the ABFS path for that specific table. So it's pretty simple and straightforward. So now we have created some tables. Greg, how can we work with this table?
So in this case here, we're having a look at some examples of how this would be done. And so first up, I'm presuming here that we'll be doing this in some sort of notebook or executing Python code in some way. It doesn't have to be a notebook, but it often is. And so from Spark, you can execute SQL commands directly. So I can say spark.sql and then execute an insert statement, and that works fine. That's the most common way that I see people working with delta tables in Spark, is often to just use Spark SQL. Keep in mind, this is not T-SQL. This is very much Spark SQL. So your knowledge in terms of SQL is still very much useful, and it's not all that different in a lot of cases, but it is a different dialect of SQL that we're working with in this case. And now, if you wanted to just directly do the SQL, you can do that in a notebook as well. And so we would add what's called a magic. And so we say %% SQL, and then I can execute update products, set the price where product ID is 1, and so on. That works just fine. Another way, though, is to call the Delta API. And so if you want to work with Delta files rather than directly with the tables, there are scenarios where it's easier to use the Delta Lake API to do the work. And so in this case, in the Python, I've said from Delta tables, import all the libraries in there, or the functions, and from PySpark SQL functions, bring them in. And then we've just defined a couple of things. So we said, look, the Delta path is going to be under files, my table, and Delta table I'm defining as for being Spark and on that path. And then if you look at a typical update style statement, I say Delta table, but notice that the update isn't a SQL command. It's a method being called on the Delta table object. And so I say Delta table.update, in this case, condition is, so that's the where clause, category is accessories, and then set price is price by 0.9. Now, I can also use time travel, I mentioned earlier, to look at earlier versions of what the data's like. And so there's a couple of things I can do. All the modifications are logged in the tables. And so in a SQL notebook, I could say in a SQL cell, or I could say %% SQL, the magic, if I describe the history of the products table, what I get back is details of the operations that have occurred on that table over a period of time. So notice version 0 was the initial one here. So I created the table. It was a managed table, and we see the properties in there. This is coming from the transaction log for the Delta table. Then done a write, and then done an update after that. And so all those operations are recorded. Now, why that becomes useful is I can do time travel. So if I wanted to say, show me what the data looked like at a particular timestamp, this is what I can do. So I can say, I'm going to have a data frame. I'll say Spark read from format Delta, but an option timestamp as of, and then put the date and time that I want that to be, and then load the data from that path that I defined earlier. I can also do a specific version of the data. So instead of timestamp as of, I can say version as of and 0. And this says show me in this case, the original version of the data. Another thing that's been popular in the Apache project have been streaming data. And so as part of Spark, there's a concept of Spark streaming data, and we can use these delta tables with the streaming data. So all the things we've looked up until now have been static data, but it's also common to process IoT readings or sensors off vehicles, all sorts of different things that send information in a stream instead. And so if we're using this, the typical structure is we have some sort of input data stream. We've got Spark streaming as the thing that's handling that, and we get batches of input data appear from that then go into the Spark engine, and then we process them sort of batch by batch. Now, to use that, we can either have the delta table as a source of data, which is probably less common, depending upon what the type of operation we're trying to build, or we can use it as a data sink to send it to at the other end. And so if you look at a delta table being used as a streaming source, again, brought in both those same libraries, except I've grabbed SQL types as well, and then said, look, a stream data frame is Spark read stream, format delta, and then I've said ignore changes true, but I've said load from an area called file delta internet orders. So this is where I've been dropping the data, and then I'm going to pick that up as a stream of data to then use for other downstream processes. In this case, they've just done a stream DF show just to look at what's in it, but normally it would be the processing of it would happen at that point. And then in addition, you can use this as a streaming sink. And so in this case, again, the same functions being brought in. We've defined the input path, but then we've said, look, I want to have a schema. And so there's a JSON schema. Now, in this case, this isn't following any particular standard as yet. It's worth noting that JSON schema is a concept that's currently in sort of draft form, and I expect to see that become more prevalent over time. A bit like XML ended up with XML schemas and things, JSON will end up having schemas that we can sort of validate the data against. But in this case, it's not talking about that. It's just saying, look, I'm defining what the structure is of the types of data coming in. So I've got a field called device, which is a string. I've got a field called status, which is also a string. And then from there, I've said, look, read stream using this schema and put max files per trigger. In this case, it's just one, but from JSON, and here's the path that it would be from. And then to write the data, I've said table path is files delta device table. Notice these are still files at this point. They're not tables. And then I've got a checkpoint path. We'll talk a little bit more about checkpoints later. But then the delta stream, I'm writing that out, provide the checkpoint location, and then just say start. And then that'll start streaming to it. We do all the processing, and eventually we call stop. And so I think it's time, Mariano, for you to show people through how it actually works.
Sure. Let's do it. Let's put here the browser. So this is a SaaS experience. So we'll log into the appfabric.com with our user, and you will land on this screen that will show you all the activities that you can perform on Fabric. For this specific lab, we are going to choose the data engineering workload. And once you get here, the first thing that you need to do to start working with Fabric and Delta tables is create a workspace, okay? So basically, a workspace is a logic unit that you will have to put all the Fabric artifacts inside. And of course, you can give a capacity to work with these engines and all the security and governance for these artifacts. Okay. So I know, Greg, if you have any comments here on how people manage the workspaces, because that's a common question.
Yeah, it's a tricky one. I find people use them for different reasons. We now have a concept of environments, but earlier on, I mean, a really common thing that people would use different workspaces for different environments. So if you had a sort of a test, a UAT, a production, things like that, we have different, better probably ways of handling that sort of thing now. But typically the things that I put into a workspace are things that need to be developed and tested together, and usually things that are being worked on by the same group of people.
Right. Okay, so the first thing when you create a workspace is obviously put a name and a brief description. And if you're using domains, which is most advanced in terms of if you're using like a data mesh approach for using cross workspace organization in your work, you can assign a domain. If not, it's optional, and you can tweak a little things here like the licensing mode. So if you're going to assign a capacity, this is basically the size of the how much you can consume. So I will start with premium capacity and create the workspace. Okay, so it's pretty straightforward, it's quick. And now we have the workspace.
Note too, Mariano, I often wonder, do you tend to ever put images on workspaces? I notice that's always been an option.
That's quite new for me. I'm not as good for designing and that kind of stuff, but I saw.
The reason I say it is if I look at things like Azure DevOps, where we used to do in projects, you get the option to add an image, and at first I thought, oh, why would you bother doing that? But now, when I look at projects where we have images all over the place, I almost never read the words. I just go straight to the picture.
Just go to the picture.
Yeah, and I have a feeling that'll be the case with workspaces too over time.
Right. And I saw one implementation that they use basically colors, so they know when the red one was production, and just they click on the red one. Okay, now we have created the workspace. The next thing that we're going to do is basically create our lakehouse. Okay, so learn data lake, for example. Okay, so we are going to hit create here, and now in the background, Microsoft Fabric will create our lakehouse. Okay, so here we have, now it's created. In the meantime, Fabric will create an SQL endpoint to do SQL queries as regular T-SQL queries, and you can connect external application to this endpoint. Okay, so it's created, and now we have the basic structure of a lakehouse, which is our tables and files. Okay, and regarding the learn module, the first thing that we need to do is basically upload a file. Okay, so I will create here a new folder. It will take the name products, for example. I hit create. Now I have my folder, and I will create a file inside here, which I have already downloaded from the examples of the learn module, which is a CSV file for products. I will upload it. It's done. And now I should see the CSV file here. I can click on it, and I will have a preview of the data inside of it. Okay, so this is just uploading a file into the lakehouse. It's not a table yet. So the next thing that I can do is open a notebook, okay? So we'll create a new notebook. And this notebook is attached to this lakehouse, okay? So this is the basic experience of working a notebook. Let me, I cannot see, it's too big, the screen. Let me see if I can go here. Let me just adjust just a little bit. Okay. Let's go here. Okay. Sorry for the interruption, but I have to zoom in so you can see all the text here. So this is the notebook here. And so we are going to do just reading this file that we have here, the CSV with Python code, okay? So you can do two things on the notebook side. You can use the Markdown language to provide titles and code description. So we are going to read the CSV file, okay? And we add the code here. So we are going to use Python, and we are use the Spark read command. We are specifying the CSV type of folder, the CSV type of file. We are going to say that they have headers, and the location will be files, and the subfolder is products, okay? And we will display this data frame. So let's hit the play button here. It will take a couple of seconds because it's the first time that we are using this engine. So it will take a couple of seconds than normally do. Once it's started, it will take less time. So here is connecting. Let's give it a couple of seconds to get the things ready.
Yeah, people often sort of think, oh, that's really, really slow at executing. But note that it wasn't executing at that point. It was
Exactly.
just actually connecting to a cluster to then start doing the work.
Yeah.
And
so now it
connected
took
all good.
seconds to start the session. So now it's going to read, and it will give us the result. Now it's running, and we have the results here, okay? So now we have read a CSV file into a data frame in Spark. So now this is in memory. We can keep working with this data frame, okay? So the next thing that we are going to do is create a table based on this data frame. So now we're going to add is this Zoom. Okay, we are going to use the data frame write command. We are going to specify that this is Delta, and we are going to save it with the manage products name. Okay, so we are going to hit run. And now we are going to see that we will have a new table over here.
It's worth noting too, I think, for people coming from other types of languages and environments, just the importance of having these things sit in memory in a context. So it's unlike some languages where you get a block of code and you execute it and everything has to happen in that block of code. This is able to create objects that stay within that Spark context, and then you can keep referring to them.
While you get this session up and running with this green icon here, you will have all the memory things just available to work with on this notebook experience. So the job finished, and we have our table here that we have already created from this data frame. Okay. But what if we want to create an external table? So we are going to use create an external table. And we are going to use the Spark command write, as we were working previously. We are going to save it as delta, but we are going to use the external name, external products. And in this case, we are going to use the path property, okay? And we are going to add the ABFS path, okay? This is the folder that we want to use for this external table. Okay? So in this case, I will go here to my lakehouse, and on the file side, I will double click on the 3-point side and copy the ABFS path. I will copy it and replace it here. Click on here. And now I hit create. So basically the data frame that which is in memory, I will create an external table with all the data. Okay, the Spark shop succeeded. We are almost there. It ran 23 seconds. I hit refresh. And now I can see that I have a new folder for this table that contains all the files that Greg explained before. So we have the Parquet file and we have the Delta log as well, okay, for this table. And if I go here to the table side and I click refresh, I will see both tables, okay?
Is it worth, Mariano, maybe just opening that log file or something just so people can see, or one of those JSON files, yeah, just to see what's in it? You'd probably have to, drill into the actual files area. Yeah, it might be a bit tricky for the moment, but yeah. I think if you're stepping through this, when you're doing this yourself, be worth going and having a look at the file locations and things, and then have a look and see what's in those files. There we go.
So basically it has the information of the commit. Okay, so the operation that create this log was the create table as select. Okay, and that's the only operation that we have made on this table. So it's the only log that we'll have. Okay, let's go back again to our notebook over here. Okay, so how can we compare which type of table? In this case, we put names to identify which are external or managed, but what are the cases that we need to know if a table is external or is a managed table? In this case, we have a command here. We are going to use the magic command and change our language to SQL. You can do it from here with this magic command, or you can use the selector here to change from Python to Spark SQL. And the command is describe. If you're like me, a SQL Server person, this command is much like the same as the sp_help to retrieve everything from a table. So you can use it. And let's go click here. And we can see the definition of that table with all the columns and the type of the column. And here we have the type, which is manage in this case, and will give us the location. And of course, it will be on the tables folder that is completely managed from Microsoft Fabric. Now let's change the name of the table, and we can use external products. and hit describe, and we will see which is the difference between one and the other. So same exact 4 columns, but now the type is external and the location is the one that we selected when we created the table. So describe, it will give you the information of the table and what type of table you are using it. Okay. Now we can delete tables. Okay. And we are going to explore what happens when you delete a managed table and when you delete an external table. So we are going to use the magic command SQL. So we're going to use SQL commands and we are going to drop both tables. Okay. So let's hit play. And now we're going to see that both tables are gone from the table side. But in the case of files, for the external table, it will remain the same structure. I deleted the table, but because it's external, it won't delete the data. So I can reuse it in the future. So that's the basic difference between managed tables and external tables. So now we have deleted the table. So how can we reuse that data? So let's recreate the table here. We're going to create an external table from data. Let's put the code here. In this case, we are going to use the SQL command. We are going to use the create table statement. We are going to specify delta. And in this case, because it's an external table, we are going to add the location property. And we are going to point to the same external products that we have already, okay? So if I hit play here, it finished the command. And if I click refresh, now I can see the products table. And of course, just to see if we have data inside of it, we can run a select from it. And there we have all the data that we have on these external files, okay? So now we have created a table, an external one and a managed one. We delete it, we recreate it. So now we are going to test how can we use table versioning, okay? So I'm going to use table versioning. Yep. There we are. Let's hit code. And now we're going to update our table and make a reduce on the price for the category mountain bikes. Okay, so just a regular update. Okay, it ran, and we have 32 rows affected for this update. Okay, so now we are going to see how can we see all the versions that we have on this table. And we are going to use the describe command, but we are going to describe the history. This will give us all the versions that this table has. Okay, so the first version, which is number 0, it gives us the create table, which is the first commit that we have on the log on the Parquet files. And the version 1, it will give us the update command that we have already done. Okay, so we have these both versions here. Okay, How can we take benefit from this? So, okay, we can create some code and compare both versions of the data. That can be pretty cool if you are using, for example, slow changing dimensions or anything that your business needs to recover what was the table at some point of time. So I ran this command. I created two data frames. The one will use the current data, and the other data frame will use the original data. So I click run, and we can see that mountain bike, for example, the row number 1771 product ID has the price. This is the current version that has $3,059. And if I go, to the other one, which is the original version, I can see that this has the previous price. So that's kind of cool. You can switch at certain point of time of your tables just using the versions that you have on the log files. And finally, as Greg told us, we can use the Spark streaming engine. So we can emulate and work with some IoT or streamings of data and put all that streaming into a sync into a Delta table. So we are going to use the streaming. And let's add some code here. Let's copy here. All this code is on the learn module, and we are just following the exact same code, so you can do it at your own pace. And as the same as Greg mentioned, we are going to add some libraries here for types, functions. And the first thing that we're going to do is create a folder. So all this streaming of data will land on our lakehouse. And then we are going to give us the schema for this stream, okay? And finally, we are going to write some data on this stream, and we are going to put it on a file. So let's go and start playing this. And the source stream is created. So if I go here and refresh my file site, I will have a new folder, the data folder, and that will have the data txt that I have defined here. Okay, so I just emulated a stream of data that is putting here on the lakehouse side. So the next thing is how we can take this stream into a Delta table. So we are going to add a new code here, and we are going to write this stream directly into the table that we have defined here on the code, okay? So we are going to define a path for this data. We are going to create a checkpoint path, and we are going to use the IO stream to write this information into a Delta table, okay? So let's play here. And now we are streaming from the source into this Delta table. So every data that comes into the sync, it will appear on our table. So let's take a look at the data from this table that we have already created. We can refresh here on the table side, and we are going to see that we have the IoT device data table, okay? So running a SQL command, we are going to select star from this table, and we should see the exact same rows that we already populated on the file, okay? So here we have all the files. Here, that is the same data that we put on the event data. So let's do some updates, simulating that we have a new stream of data. So we are going to add more data, but we're going to add more data on the stream side, okay? And the Spark engine should put this new data automatically on our sync table, okay? So let's check now. The new data has come, and we are just going to select our table. And now remember that we have 9 rows. We added more data, and now if I query the same table, I will have 16 rows. So basically, this is how we can leverage this capacity for the Spark streaming engine. And now finally, we are going to stop the stream just to reduce the consumption. And that's all that I have here, except that we should clean up all resources when we finish this lab. So the easiest way to clean up all the resources is just to delete the workspace, because if I delete the workspace, everything on it will go away.
Mariano, just one quick question. Do you happen to have OneLake Explorer on your machine?
Yes, sir.
Because a couple of people were just asking if you can show what's there so they can see what's in the folders. So.
Okay. I think it's here. You can download the OneLake File Explorer, which is an desktop application that you can install on your computer, and it will use the Lakehouse APIs, so you can browse all the files that you have on your Lakehouse as if it were like a OneDrive experience. Let me show you here. OneLake app. Oh, it's running. Let me take the here. So I have already installed the application and connected with my user. So my user is currently seeing all these lake houses that I have on my users. Okay, so this is
Currently,
lake house.
that's still showing your browser screen at the moment, Mariano.
Oh, it doesn't show you StreamYard. Okay. Let me see if I can represent here the entire
it might have been
screen.
a window rather than the screen. Yeah.
Let's see if now appears. Yeah, there we are, right?
Awesome.
Okay. So basically what I did was going here to the application that I have already installed and connected with my user. So it presents me like a OneDrive experience, but this is connected actually to all the workspace that my user has permissions. So I can see here a lakehouse, and I can see tables, and I can see files. Okay. So I can see all the Parquet files and the Delta log files as well. Okay. So this is kind of cool. You can upload or download files like if you were using a OneDrive experience, but for your lakehouse.
Yeah, that's great. And so one of the things that you can do, for example, if you're trying to get data into this, is you could take data off your local machine, copy it into those files folders, and then allow it to sync up from there.
Yeah, totally.
That'd be a bit slow though if you were doing really big files, right? So,
of course,
yeah, there are alternative options, yeah, for copying big files. Yeah.
You need to assess the next session that will be using data pipelines that is specifically for moving data into the lakehouse. So we are just finishing this. So to clean up all the resources, I go here to the workspaces, select the current workspaces, and go to settings. And here on the general tab, at the very end, you have the option for removing this workspace. Okay. So you click delete, and everything on it will go away. Of course, you have to have the right permissions to do this. If not, you won't have the permission to delete.
Yeah, I think it's an important concept if you're new to this, just that the external table is not like a real table with a bunch of data. It's a pointer to where the data is. And so one of the powerful things in this is we can have, for example, shortcuts that go across to data that's in other storage systems, like in AWS or other cloud providers, or increasingly, I think we'll be able to do any S3 provider and so on. So there's a variety of these options, but basically it allows you to treat it like it's a table in your local system or in your local workspace. And importantly, it allows you to then do things like joins between the data that you've got locally and the data that's in some other storage system, or even between multiple storage systems and so on.
Yeah, that's pretty common scenario right now, that organizations has a multi-cloud deployment. So it's very common to see that you have data that you want to match up with your own data. And this is one of the great things that Microsoft Fabric can do, is like putting external data into your environment and querying the data as if were in your system. So that's very an impressive thing.
Awesome. And so, Matt, we might head across to some questions just as a knowledge check. And then while we're doing that, if we'll just tidy up and work out what other questions are in the chat. Once we get through the knowledge check questions, I'll have a quick wander through the chat and see what's there and not answered and so on. But if we start with this, so with the knowledge check questions, for each one of them, there's a little link down the bottom left there and a QR code where you can go off and vote for those. I get Mariano will check what the poll is for each of these, and so the first one's just, which of the following descriptions best fits Delta Lake? And so not Delta Table, but just Delta Lake. And so a Spark API for exporting data from a relational database into CSV files, or a relational storage layer for Spark that supports tables based on Parquet files, or a synchronization solution that replicates data between SQL Server and Spark.
Okay, here are coming the votes. Let's give it a couple of seconds more. Okay, I think we have a winner.
I hope so. Yeah.
Yeah.
So, yeah.
Most of the votes are, totally. Yeah, they come as a streaming data. Yeah.
Right.
We have most people going to the B answer. That is a relational storage layer for Spark that supports table based on Parquet files. So,
right.
great
So
people.
the second question says, again, we've got the link there. You've loaded a Spark data frame with data that you now want to use in a Delta table. So what format should you use to write the data frame to the storage? It's a little bit trickier.
A bit tricky. Okay, they are coming the votes. Oh, we have a couple of different answers here.
That's what I suspected. Yeah.
Yeah. But okay, most of the votes goes for the C answer for Delta. We have a bunch of that are C Parquet and way less CSV.
CSV. Okay. Yeah. So the
But
important
most
thing
of the answers
here,
are going for C Delta.
yeah. And so, look, the important thing here is that even though Delta files, Delta tables are built over the top of Parquet files, the fact that something's a Parquet file isn't enough by itself. So for us to be able to use these as delta tables, we have to have the structure that's provided by the delta tables. And so in that case, what we get is not a file like Parquet, is we get the folder that contains 0 or more, really 1 or more usually, Parquet files. It then also has the log file folder where we've got the log files in there. And in addition, we have checksum files. Now, I mentioned those earlier, and I did say I'd mention a little bit more about what that's about later. And so a good time to do that right now. And so the idea, we saw time travel, and with time travel, you've got the idea of saying, show me what the data looked like at a particular point in time. Now, imagine if you had log files that go on for a very, very long period of time, and then you said, show me, back to a certain point. You could end up having to process a lot of log files to get to a particular point. And so to avoid that, what they do is periodically create check files that are basically saying, look, this is where we're up to at a particular point in time. And so checkpoint files allow us to do that. And then we only have to start from that point. And so that can drastically reduce the amount of time required to do time travel.
Yeah.
Right, so let's have a look at the third.
Files are also used for the maintenance side of the lakehouse. So
Yep.
let's talk about later about that. But let's finish with the questions. And
so the third one says you have a managed table, importantly managed, based on a folder that contains data files in Delta format. If you drop the table, what happens? And so the table metadata and data files are deleted, or the table definition is removed from the metastore, but the data files stay intact, or the table definition remains in the metastore, but the data files are deleted. So the third one is, does it just empty the table?
So here are coming the votes. Oh, it's tied.
Tied? That's interesting.
50-50 right now. Okay. So basically, we have now, interesting. We have 52%, which is A, 42% for B, and C is just 1 vote. So it's 4%.
Okay.
So, but we're almost tied. Okay.
Well, yeah, closer than possible. All right, so it is A, and so this is the key difference. When you have a managed table, the table has the metastore information, the metadata, and it also has the data files. And so once you drop that, you're dropping the whole thing. In the case of an external table, if the question had said an external table, then all the external table is the metadata that's pointing at data that lives somewhere else. And so what happens when you drop the table? It doesn't dive over there and delete the data from the place it's pointing at. What it does, it just removes the metadata. And so in the case of a managed table, think of it like a table in any other sort of storage system. You drop it, it's all gone. But in the case of an external table, it's almost more like if you imagined a view in a traditional database. If you drop the view, you don't drop the table when you do that.
Exactly.
Okay. And so look, to summarize with this, before we finish off on this, I want to have a look at where we're at in the chat. There was also something else you wanted to mention, Mariano?
Yeah. When you have all these checkpoint files and all the log files at the end of the day, when the table grows and time goes by, you will end up with a lot of log files and checkpoint files. So one of the operations that affects performance is how many checkpoints do I have to read, or how many log files do I have to read. So there is a specific maintenance operation it's called vacuum and border, that will compress all these logs into the current one. So just to speed up the process of reading those commit files. So that's more for the administration piece and the performance side, that you can do this in order to improve performance.
Okay, so a few questions in there. So Donald asked, can you partition manage tables, and when should you? So is that one?
Yes, of course.
To tackle that?
Yeah, of course. You can partition your tables if you already know which will be the distribution. And of course, if you're going to then access that table by that partition, that will benefit you for the performance side. And of course, you can do it when you create a table. And if you have already created a table but not partitioned, you can create a new table based on that and create the partition necessarily.
Also, Wendy asked about environments, and note that Wendy said she was going to have to leave early, so maybe on the recording she'll sort of see this. But the thing with environments is that traditionally what you really want is you want deployment pipelines that take things through various stages. So it's kind of like I do development work, I release that into some sort of test area, maybe that gets pushed to another stage where or another environment in different terminology, where maybe that there's then a UAT. And then at each stage, what you usually want to have are things like approvals and so on. So it's like somebody has checked this off before it moves to the next stage. But usually all of those things are sort of associated with each other. And we have had beginnings of that in Power BI in the way they did environments. It was not like I would have really loved the way that was done, because I'm more used to how it's done in Azure DevOps and GitHub and areas like that. And I think what you'll see over time is there's a move more to supporting normal continuous integration, continuous deployment, things like that. And so I'm hoping that we'll get to a point where that's more like how these things will be treated, rather than just having completely separate workspaces where all those things occur. Also in here, there was a little bit that someone added to that. Show the external location. Yes, we did that. Indexing, do we still need to manage those? That's a topic for another day, that one.
Totally.
But there are things that we have to do
here
in terms of the structure of the files. And so, yeah, Mariano?
No, sorry, go ahead.
The first thing I was going to mention is that what we haven't sort of talked about as yet are things like the structure of the files more so. So, for example, do we have the data in the file in particular order? And again, there are controls over things like that. That will affect things like how well the compression works and so on. And so we talked earlier about run length compression and things like that. Clearly, if things were sorted in order, that would work better, in certain things. The other one is there's a decision around what's the right size files. And so should we have lots of little files, or should we have, a small number of big files and so on? So there are optimization options around that, and that becomes important. Another one is that you can imagine that as we delete things, there's a certain period of time after which we're not even referring to some of the things that are part of the Delta format anymore, right? So we get to a point where we don't need some of the files, for example, that are referenced inside there. And so there are concepts like vacuum operations to go through and remove those as well, because again, you don't want to be wading through those and so on. So there are a lot of things to do with handling the files. It's a different story. Now, is indexing still around? Certainly, if you look at the SQL, like the warehouse side of things, that's very much still the case there. But this is really more around optimizing the files and so on at this point. Is there anything you want to add to that, Mariana?
You explained it perfectly. So
no, it's all good.
Yeah, it's a trade-off. You have to at least take a look at that kind of things when you have big files or tables with a lot of rows and a lot of updates going on. So yeah, that's particularly when you have to take a look at those pieces.
Look, Donald also asked, what's the red triangle warning that was on the left?
That's my fault, because I was playing around, deleting and recreating the same notebook experience. So in my case, I put the same exact name of a previous notebook that I had. And of course, I changed my lakehouse connection. So it was saying, hey, you created this notebook and it's not connecting to the original lakehouse connection.
Yeah,
So
it's good. It was actually sort of warning you that you're actually playing in somewhere different to what it was thinking you would be. So all good. Okay, so we had Trino.
Yeah, the external tables are type of data virtualization.
Certified connector for Trino. No, sorry, don't know about that one.
Yeah, I think that the concept for data virtualization, it's more or less the same, because you are using external data that resides in a different cloud provider, for example, and you're building a structure in your own infrastructure of Fabric to query that external table. Yeah, so it can be considered as a data virtualization.
So we might then start to close out, Matt. And so in summary, so this was understanding Delta Lake and the Delta tables in Fabric, creating, as we said, how to create and manage the Delta files or Delta tables, and using Spark to query those, and a little bit about structured streaming. I apologize that as soon as I started talking this morning, the retired man next door decided to start mowing. So I don't know how much of that sound came through, but that's life. He's not normally awake at this time of the day. So anyway, hopefully that didn't go in too much. But Mariano, where can we find more documentation and so on?
Okay, you can go to the Career Hub, of course, but you have all the Learn and Docs information for Data Lake tables on the documentation side. So we have this QR code here, and you can go directly to the documentations. And of course, keep working on the Learn module. Remember that we have the Cloud Skill Challenge still going on. So you can join, complete all the exercises and all the modules here at the Learn side, and you will have the 50% voucher to apply for the certification exam. And of course, don't miss the next session that is happening next Tuesday on 9 a.m. Australian Eastern Time to continue the learning.
Awesome. And of course, this is only one of the set of sessions that we've got. So this, if you didn't get a chance to watch these all or participate in them last time, there are online copies up at YouTube of the previous versions of all of these. But this round, they'll be going up. There's obviously a benefit if you can join in live, and we encourage you to do that if you get a chance to do it. There's also the exam discount that was mentioned earlier with the Cloud Skills Challenge. And this can help you get started with this is with the DP 600 exam. I was actually one of the authors on that, so it is one that I know intimately. And so one thing I'd say with this exam, there's a lot of good material on the Learn site itself. There's a number of people, particularly Nikola Illich, has provided a whole lot of additional stuff at his site with things about how to learn to get prepared for this. One thing I would suggest to you, though, if you're tackling this, it's important to make sure that you've covered all the topics that are discussed in the study guide. I have seen a few people felt like they got a bit of a shock in terms of the amount of stuff they needed to know. It's not that bad, because whenever you have that sort of breadth, you don't have incredible depth, on all of those things. But there is a wide variety of stuff that you do need to know for this session. And so it's not a case of, do I do it just in Python, or do I do work in SQL Warehouse and so on? You do need to know how to do both, as part of that sort of exam. So just make sure you have the appropriate coverage on that. So that's one area I've seen, is I've seen people think, well, surely I don't have to know all the different ways of doing things. But in fact, for the exam, you actually do need to do that. Out of things I've seen from people doing the exams, I would strongly encourage you, when something doesn't seem to make sense to you in the exam, please just go back and reread it really carefully. I've seen people who were telling me about things they saw, and they were saying they couldn't work out with, and they kept going on and on about fields, but in the thing, that was actually talking about files. So the thing that's really important is if you really find yourself getting stuck with things, make sure that you're not sort of misreading something or so on. I just can't stress enough how important it is to make sure you really, really do thoroughly read the questions and look for the things that are important in that. But I don't know, have you had a chance to do that as yet, Mariano?
Yeah. I'm still waiting the results, but fingers crossed. From my side, my experience, I'm more from the data side, not from the Power BI side. So that's for my case that I have to put more attention on it.
And so, look, that's the thing. A lot of people coming from the SQL side would say, hey, there's a bit of Spark and Python that I need to learn, right? And so on. So, yeah, that is true. And even if you've worked with things like Azure Data Factory, that's a really good start for working with Data Factory and Fabric and so on. So there's a lot of skills that are directly transferable into Fabric as well.
Sure, totally.
And so, look, we thank you very much for being involved. Thank you, Mariano, for being the co-host today.
Thank you, Greg. Thank you very much for having me as a co-host here. And of course, thank you all the moderators and producers for the show.
Awesome. Thank you all.